All right, we're looking to rationalize the denominator here. And we got this rule in math that you are not allowed to have a square root in the denominator. So in order to get that out, what we're going to end up doing is multiplying by, well, effectively we're multiplying by 1. It's just not going to look like 1. Here, I'll make it kind of like a big fat 1. We're multiplying by 1, which we're allowed to do. But that 1 is kind of a funky one where the top and the bottom are the square root of 3. So in order to get rid of this radical in the bottom, we need to multiply by that exact same radical. The square root of 3 times the square root of 3. When you multiply that out, it will cancel. If you're not seeing it yet, you will as we move forward. So multiplying by 1 won't change the value. Square root of 3 over the square root of 3 is 1. You'll see what happens up at the top. This is 6 times the square root of 3. I referred to them earlier as like an outside number and an inside number. So what's outside the radicals stays out there. That's a whole number. And then this is the square root of that 3. The 3 is the radicand. It stays inside. And that square root keeps them from multiplying. They just squish up next to each other like you do with a number and a variable. Now underneath, we end up with the square root of 3 times the square root of 3. And one of the properties that we discovered is when you're multiplying two individual square roots, you can actually multiply the two numbers inside. That's different than what we saw up here because these are both radicands. These are both inside numbers. So they can go underneath together. The top is going to stay 6 square roots of 3. The bottom becomes the square root of 9. 3 times 3 is 9. 6 square roots of 3 stays up top. Square root of 9 is a perfect square. That's what we wanted to happen. We want to take the square root of what's underneath and get a whole number. So in the denominator, we end up getting the square root of 9, which is 3. The top gives you 6 square roots of 3. And that did get the square root out of the denominator, and it is equal. Like if I grab my calculator here and I do 6, I'll clear that all out. So we just got 6 divided by the square root of 3. It's a decimal equivalent of about 3.46. Now, if I type this into the calculator, now one thing to keep in mind, if you're typing it into the calculator, you should put parentheses around the entire numerator. So I'll do 6 times the square root of 3, close my parentheses, divide that by 3, and you'll see I get the exact same decimal equivalent. It's the same thing. Now, one extra step that we have to pay and keep in mind here that happens anytime we're working with fractions is you potentially will have to simplify. And that does happen here. If we think about this as 6/3, right, 3 goes into both of those numbers. Or think about it as a division problem, 6 divided by 3. Either way, however you internalize it, those 3's are going to 3 is going to cancel out of each one of those, and we're going to end up with 2 square roots of 3. Now, that actually ends up being our final simplified answer. And once again, I can use the calculator to verify that this is the same equivalent decimal to times the square root of 3. Same answer every time, no matter what stage I was on, because I didn't change the value. I'm just simplifying. Look, I just multiplied by 1. Multiplying by 1 won't change any value. Last thing I might want to point out here is there's actually a little bit of a shortcut, which is really, really handy. What happens always is that whatever radical's in the bottom, in this case the square root of 3, notice that it moved up to the top. That entire square root of 3 got moved up to the top. Then what also happened is our denominator, that 3, it just lost the radical symbol. Okay, so I'm going to do this next one here. We got another one here where we have a square root of 5 in the denominator. I'm going to do this one using the full method where we actually do multiply by the funky form of 1. But I'll verify that the shortcut would work. So we're going to multiply this by square root of 5 over square root of 5. Again, this equals 1, so we're not changing any values. When we multiply fractions, we just multiply straight across, so we end up with 4 square roots of 5 here. In the denominator, this is square root of 5 times the square root of 5. So that becomes the square root of 5 times 5. Since they're both square roots, they're being multiplied, we can put them both underneath. So now we got the square root of 25, which is good. That's what we want. That's a perfect square. 4 square roots of 5 is just kind of hanging out this entire time. Not much you can do with it. We're just kind of working along our way on the bottom. We now have the square root of 5, which is 5. And this one does not require any extra simplification because 4/5 cannot be simplified, which is a really good opportunity to see the shortcut. The square root component moved right up to the top. And the denominator, which was originally the square root of 5, it just dropped its radical symbol. So to just write my final answer without having any highlighter on it, look, I can take the 4 that stays in the top, I move the entire radical up, and then the bottom, I just lose the radical over that number. So that would be my final answer. And again, I can, in the calculator, verify that all of these are the same if I do 4 divided by the square root of 5. I get this decimal 1.7 and then a bunch of 8s. And if I do the same thing over here, and again, typing into the calculator, you do need to put an extra set of parentheses around that entire numerator, everything that's in the top. 4 times the square root of 5, we divide that by 5. Oops, yeah. And look, same decimal equivalent. So this and this are the same. All right, let's take a look at one more, and let's go ahead and just apply that shortcut. So I'm not going to show the whole multiplying by 1. What I'm going to do is I'm going to keep my 12 up in the top. I'm going to move this entire piece up to the numerator, and then the denominator just loses that radical symbol. That has rationalized. It's gotten that square root out of here. I do have one extra step here because 12 divided by 3 goes into both of those numbers. So I'll end up with just 4 square roots of 3. That is my final answer. That has been rationalized. There is no square root in the denominator anymore, and math is much happier. So again, I'll just verify that it works. 12 divided by the square root of 3. That's about 6.9282, lots more. 4 times the square root of 3. Same answer, same decimal equivalent. Hope that's helpful. Message me anytime with questions.